Okay, we're live. So, hey guys, my name is Jan and I'm from DoraHacks. Welcome to our third workshop today of the Hack AVS Empower the Eigenlayer Restaking ecosystem. And before we start, let me give you some background on this hackathon. As the largest Web3 developer incentive platform, it's an honor for DoraHacks to support and host this Hack AVS hackathon. We're really excited to seeing all the amazing projects building on top of Eigenlayer. And today we're very happy to have Ranvir. He's the co-founder of Witness Chain and also Peiyao, head of research at Witness Chain, doing a workshop about Witness Chain and the DePIN coordination layer. So if the audience has questions at any point, feel free to drop them in the chat section or in the comments. We're happy to do or answer them towards the end. And whenever you're ready, please feel free to start.
Perfect. Thanks for having us here. I'm Ranvir. I'm the co-founder of Witness Chain. At Witness Chain, what we are building is a coordination layer to unify DePIN economies. And the purpose of this hackathon is to develop new ideas of coordination across DePINs. Now, in the presentation during this workshop today, we'll go over what coordination means. We'll go through a few examples and how you can develop on top of this layer. So with that, we can start the presentation. Perfect. So what does unifying DePIN economies mean, right? In some sense, what we are building is an equivalent or eigenlayer, but for DePINs. Now, to give a little bit of background behind physical infrastructure networks, these are networks of typical physical assets. Due to the nature of physics, the world is decentralized, and so physical infrastructure is naturally decentralized. Now, this decentralization has actually been a barrier in centralized economies because of very high capital expenditure that is spent in deploying them. And because of that, a lot of infrastructure has been deployed either by nation states or by monopolies who have that capital expenditure available to spend. Now, decentralization, the ethos of blockchains, has provided a way out. And we have seen a few so-called decentralized physical infrastructure networks emerge recently. You might have seen these DePINs everywhere. There's Filecoin, Demo, Rana, Render, Akash, and so on. There are a lot of these DePINs out there. But one thing we see is that these DePINs are fragmented and lack coordination. What this means is they are kind of endogenous to themselves. They don't allow, it's not like they don't allow, but it's difficult for application developers to build applications on top of them because they lack a layer of trust. If you look at examples in traditional crypto, Ethereum is the coordination layer. It builds a layer of trust between any applications, so-called smart contracts, built on top of that. These smart contracts then add value to each another. A very recent example of a coordination layer is Eigenlayer, which coordinates things that cannot be purely represented by smart contracts. These are so-called AVS, and we are one of those AVSs. What we are developing is something similar, but for the physical world, that enables coordination not only across DePINs, but also allows application builders, smart contract developers, to build applications on top of that. Applications such as DePIN DeFi, for example. Now, fundamental to building this coordination layer is a layer of trust. And how do you establish trust? Through consensus. Now, Ethereum achieves consensus on digital state, which is it achieves an agreement. When I say I have one token, anybody can trust me and be rest assured that I can't double spend it. When you want coordination on physical assets, what you need is consensus on physical state. So what you've done at Witness Chain is build out consensus on physical state. So what does this mean? So a physical asset has various attributes, be it its location, its connectivity, bandwidth, its compute capacity, storage, energy capacity, so on. We have a few of these systems developed. Fundamental of this is proof of location, which actively validates location for any connected computer throughout the world. We have proof of bandwidth, which measures the network capacity. Think of this as decentralized speed test. And proof of diligence, which ensures that any compute is performed correctly. Once you have this different consensus on physical state, what you can do is DePINs can now register their assets on our coordination layer. So there's a DePIN coordination layer. DePINs register their assets there, and they get validated by the Watchtower network. Now, Watchtower network are a set of eigenlayer operators which have deployed the relevant validation code for these proofs. Once those assets are validated, then they can be utilized by application developers to build any number of emergent applications. A few examples of how these applications, I'll just go over a few examples of how these applications work with one another. An example that I've developed here is that of a bandwidth future. So somebody can develop, so let's say there is a network DePIN. Antenna is a popular example that provides bandwidth. Somebody wants to develop an equivalent of Twilio and make that networking available to anyone at a relative ease. So what they can do is somebody can establish an equivalent of a futures exchange for bandwidth. Twilio can just buy those futures and be rest assured at the pricing of Andrina. This helps Andrina because it sells bandwidth. It allows it to sell bandwidth to the futures exchange. It helps Twilio because now it can get bandwidth at a fixed rate in a predictable manner. And the futures exchange, which can be a dApp itself, which is example of a dApp that you can actually build, can benefit by providing that market. You can build some equivalent of AVE, which is a borrow lending market, while utilizing physical assets as a collateral. So somebody who has a helium hotspot can actually use that physical asset that they bought with fiat to collateralize its loan to buy more physical assets or buy ETH or like whatever it wants, right? So a borrow lending market, but for physical assets is an application that can be developed here. You can build an AI distribution dApp. So a distribution dApp is a broader example of an infrastructure supply chain. What this means is if somebody wants to build AI, they not only want to use GPUs, they also want to use storage where the models and data is stored. They want to use connectivity where this data is actually transferred. And they would also want to use a data gathering DePIN. Now, combining all of these together can be made very easy once you have this coordination layer built out and some financial intermediary, which makes buying these assets or commodities easy and reliable. Another example is you can have redundant compute. So let's say you got GPU for your task, but you're not sure if a particular DePIN can provide you GPU at 100% SLA. But in that case, you can get redundant compute and build that as one single DePIN dApp, so that if somebody wants to get GPU compute in a reliable manner, you can in the backend combine two DePINs together to provide that reliability. These are a few use cases. Now what will help is to understand how would the coordination layer actually work and how to build on top of that. And for that, I will give the stage to Peiyao, who is our head of research, to go into the technical in-depths of how the layer works. Peiyao.
Yeah, sure. Thanks, Ranvir. So hello, everyone. My name is Peiyao, and I'm leading the research effort at Witness Chain. Today, I will provide you an overview of our technical framework for this DePIN coordination layer and explore several directions to build on top of it. So here is the main architecture of DePIN coordination layer, which bridges various isolated components and those participants together into this ecosystem. For DePIN industries, if you have your assets, you can register the physical assets on the platform in the form of tokens, and you can run your own service flow. And for developers, investors, you can also build the DePIN dApps and participate in those financial protocols around the physical assets. And if you're stakers, your operators, then these roles can also take the responsibility for providing economic security and monitoring activities in this layer. So at the core of this architecture is, as Ranvir mentioned, is building physical trust. In other words, we want to establish consensus on those physical attributes. We have developed a series of protocols that can reliably verify physical attributes such as location, bandwidth, and each of these protocols is a research breakthrough in its own field, but together they serve as the building blocks for developing DePIN applications that enjoy the physical trust, and further these trusts are anchored by the economic trust provided by EigenLayer. And additionally, our system supports the pluggable proof of anything. The anything can be some other physical attributes. This allows our community to also innovate and extend the validation process tailored for their own physical assets. And next, I will briefly go through the existing protocols developed on DCL and explore several directions that can be pursued to develop your inspirations with DCL. So one of the grand challenges we solved is proof of location. The geographic information is the most fundamental attribute for those internet participants. And as we transition to Web3, the principle of decentralization itself emphasizes the importance of this kind of geographic data even more. So the basic method, we know we can determine the location of a point is through some form of triangulation. That is, you can measure the distance to others whose locations are already known. But in those decentralized scenarios, new challenges will emerge. We need to tackle those adversarial behaviors in decentralized setting that everyone can lie. They could have incentives to falsify their location. They can use VPNs or CLUD to manipulate the measurements. And furthermore, even the distances between you and the other nodes are not directly measurable, because we need to rely on internet measurements for the conversion. So the problem is that the internet speeds also have large variations and noise due to various network conditions. And again, those malicious nodes can intervene in the process of measuring distance. So to tackle all these challenges, we propose a protocol that consists of two phases, each addressing one of the issues. The first phase uses some Byzantine-resistant data inferencing techniques to robustly translate the delay measurements into the actual distance. And the second phase combines the cryptographic primitives to securely bound the uncertainty of the claimed location. For example, a network hotspot can claim some coordinates indicating their location, for example, in New York City. And by running our proof of location challenge, our protocol will output some uncertainty of its claim, like either 100 kilometers or 1,000 kilometers. Of course, smaller uncertainty means higher accuracy. And if the node is actually located in Europe and use some VPN to claim to be in New York, then the protocol can immediately detect it by outputting some very large deviation, like 9,000 kilometers. And another set of challenges and protocols we built are used to testify those network attributes. So one example is called proof of bandwidth. Within this framework, there are two types of attributes we can verify. One is for the service link, which connects the hotspots, those network service, and the users. this kind of proof will help you measure like how much data you got and how much payment you should make during the service process. And the other is on the other side is the backhaul link, which connects the hotspot to the internet core. So then this kind of proof of backhaul tells like how good internet connectivity the hotspot can provide. And so as we also have mentioned, this proof of bandwidth can be considered as a decentralized speed test. So if you want to know your internet performance, then usually in the centralized way, you will go to this website to test the speed. But now we provide the same tool to test your internet speed while making it trustless and open. This means it can tolerate those adversarial actions and also allow servers with limited resources to join the system as a challenger to help measure others' bandwidth. So these two properties are essential in those DePIN settings. And our protocol mainly use these traffic aggregation techniques to lower bandwidth requirement for challengers and contains several interactions in the protocol to remove those single point trust. So we implement the contract to coordinate the challenge and also calculate the robust bandwidth we can output. So any DePIN application that needs bandwidth data and can easily just send request to DCL to call this function to issue a new challenge. And so returning to to this architecture, I hope now with these two examples, now you have a better understanding of what kind of physical trust we want to provide and how to develop innovative applications using these kind of proofs. And I will give you some examples and several directions that you can explore. The first part is we can build the decentralized financial services that revolve around those physical assets. This category can leverage the DCL to bring greater transparency and the security to financial transactions. For example, if you want to build an asset-backed lending and borrowing protocol, users can secure their loans against the physical assets, which are tokenized and also verifiable through DCL. And one can also create something like a dynamic insurance products that can adapt in real time based on the verified data about some asset condition and its real-time usage. And the second category is to develop dApps. So how to use verifiable physical trust and the interoperability we provide among different DePIN sectors to create new applications. Examples include like cellular data marketplace, where based on different needs and suppliers, you can match the demand and need of those networking service. Like asset management in all kinds of applications, or even like AR gaming, which needs to interact with the real world and needs to map the real world to the digital world. And the third category involves the tokenization of physical assets, where you can explore concrete use cases to trade, manage, or utilize your tokenized physical assets. For example, we can establish fractional ownership to democratize the access to investment and management in those high-value assets. And the last but not least is to propose new proof of X protocols. There are many different types of physical assets with unique attributes. So it's important to develop a wide range of proof primitives to verify them and to better integrate them into our ecosystem. So besides the developed protocols we provide here for like location, bandwidth, we can also consider storage resources, computing resources, like energy devices, vehicles, so anything that will be we can use in the DePIN world. And so, so here's the slides, which is an illustration of how the ownership of a tokenized physical asset can be programmed. So as you see in the traditional case, usually the owner of the asset will take full responsibility for the asset, including management, maintenance, or upgrades. And as a result, users who actually consume the asset, the service related to it, will make full payment to the owner. But now, when such assets are tokenized, the owner can delegate different aspects of the asset to different parties. For example, the hotspot might be deployed by some landlord, but we use some other professional manager to keep monitoring the service status. And like the owner can further lease the shares to other operators. So accordingly, all the fee revenues associated with this token, with this asset, can be split among different stakeholders according to predetermined agreements. And the DCO, those blockchain platforms, will provide you an ultimate way to execute these kind of mechanisms. So last thing to clarify the scope of this hackathon, our primary goal is to discover use cases. So we have introduced the basic DCO architecture, but we didn't define any like strict rules or structure that you have to follow. So there's a flexibility for you to expand the design scope. And the deliverable would be a report describing your plan to build a system. It can be in one of the 4 categories we've mentioned, like a DePIN dApp, or DeFi services related to DePIN, or tokenization use cases, or you can propose your own proof of X proposals, which can be integrated into our proof layer. So in the report, basically, we need to include the basic motivation, explain the what is the core idea behind the project, and some specification for the details of the technical aspects and the components in the system. And we can list some business use cases to describe how the project can be applied to real-world scenarios and the potential impact to it. And we can also detail the smart contract structure. So though we are not required to implement it, but we should outline the design and the functionalities needed for the smart contracts. And here is the link, provide a brief example about a dApp proposal for your reference. So besides the basic contents in this example, your report can include more details like a system diagram, interface design, anything that helps illustrate the practical application and the potential benefits of the proposed system. So yeah, feel free to think creatively and innovatively to push the boundaries of what's possible with DCL. Remy, do you have anything you want to add?
Yeah, one perfect example would be like, to build a futures exchange, right? The way I see blockchains right now, or Uniswap, is an equivalent of a stock exchange. But commodities exchange are bigger in volume than stock exchanges in the real world. So can you build a commodities exchange, but for smart physical assets? That's one highly lucrative project that you can build on. Another thing which uses this pluggable proof of X is, can you build something that can detect if your GPU is a real GPU or is it a virtualized machine, right? One thing that we work with our collaborators is to determine solo stakers for Ethereum. Now, it's been a big topic to determine whether you're a solo staker or just a virtualized machine pretending to be a solo staker. And you can, in fact, use our system to detect solo stakers. Now, that would require composing multiple of, like, you can think of this as like either developing your own proof, or since multiple of these proofs sit on the same layer, you can compose them together. I can give you a brief hint. You can compose location, proof of location, and bandwidth to detect solo stakers and reward them appropriately. So yeah, the scope of this hackathon is very wide, and we are open to like new ideas. You don't have to like stick to this particular format of like of building the system. We're pretty flexible, and we are looking forward to new emergent use cases of this layer. Jan, you're muted.
Apologies. So you do have two different bounties. So one is the DePIN use cases on witness chain, and then the second one is witness chain empowered rollup watchtower. Maybe you could like elaborate a bit more and share what could be like beneficial for developers once they want to build on top of witness chain.
Definitely. So the rollup watchtower network. So within this coordination layer, the first DePIN that we have deployed is an in-house DePIN. It's called the rollup watchtower network. So if you haven't, please check out our previous workshop that was hosted by Pankaj and Arun. So rollup watchtower networks are a set of decentralized nodes which are watching a rollup and making sure that their state assertions are correct. Now, since these are full nodes which are actually executing transactions, and these are full nodes backed by a huge amount of crypto economic security. So in our current deployed system, we have $6 billion worth of crypto economic security from EigenLayer. They can actually provide statements about the execution of a transaction. Then you can build applications. You can actually code applications on top. So you can build bridges, you can build keeper networks, and so on. Now, that's actually a system that we have deployed on mainnet. You can go and program it, build applications on top of this, and in fact, launch those applications right now if you want. So that's a very specific use case of a DePIN build on top of us. This hackathon targets more of business use cases where you don't actually need to deploy a smart contract, but give us a proposal. And if we'll rank those proposals, and if the proposals are good enough, we can actually incubate those proposals within our team.
Thanks for the extensive answer.
Thank you.
So maybe for the audience, if you have like any other questions in the meanwhile, feel free to drop them in the comment section. If you guys would want to add anything, please let me know.
That is it from our end. Peiyao?
Yeah, I think, yeah, I'm good so far. So feel free to ask any questions or ask for any clarifications.
Okay, so I think
please. One thing is you can join our Discord or reach out to us on Twitter, like if you have any questions.
Yeah. So if you haven't joined their Discord, for the audience, feel free to do that now and ask any questions that might occur after watching the video. And so thank you so much for your workshop today and joining us today. It was a great presentation, very insightful. And we're looking forward to seeing all the incredible projects building on top of EigenLayer and also on top of Witness Chain.
Thank you, everyone.
There's one question. So like, do you have a global view of all networks on your system on Google Maps or something?
This is a great question. So any network deployed on top of us will run a prover. So we have the system deployed on testnet. So Peiyao can expand on what we had deployed on proof of location. But any DePIN that works with us will run a prover. The prover, if they're running a prover for proof of location, they can automatically we can automatically place them on a map. Right? That way, you can be rest assured that like whenever you have a deployed system, you will have a view of which all assets exist in the system and what the location of those assets are and what the bandwidth of those assets are and so on. So in your application, you can assume that in your use case that you're developing, you can assume that location and bandwidth and correctness of compute is already deployed, and you have access to those properties within your smart contract. And if you don't, you can actually trigger a transaction that gets that property for an asset.
All right. So once again, thanks a lot, Ranvir, and also Peiyao. If you guys haven't joined our Discord, feel free to do that now. And we're also hosting another workshop tomorrow. So feel free to also subscribe to our socials and join the other workshop tomorrow. But yeah, I guess that's it. If you have any final remarks, please go ahead.
Yeah, this opens up a whole new side of smart contract development which didn't exist before. And you can think of yourself as explorers into this whole new DePIN field. So I'm very excited about to see what applications come up.
Yeah, likewise, excited to seeing all these incredible use cases and new use cases.
Right.
Then thanks a lot and see you guys.
Thank you for having us here. See you.
Thanks a lot.